Thanks, everybody, for coming. Congrats, you made it through the event. Thanks for coming to the very last talk. And after the party and everything. Woo. Nice. I hope you had a really, really good time here in Vegas. Kind of hard not to. You know, it's kind of Vegas. So my name is Pablo Castro. I am a technical lead in the team at Microsoft that thinks about data. And we work on a number of technologies, most of them around how to program to data, how to build applications that interact with data in many different ways. Like this goes from how do you build a C application hitting ODBC directly against a database, all the way up to how do you do objects and how you do domain modeling and what it means to do data services on top of that. And so among other things, like as a team with the charter of thinking about data, one of the things we've been thinking about lately is what does it mean for the web? Like now, every new application is like, or most of them are web applications. And so there is this clear question of, well, now that the world has the internet between every client and every server, how does data play in that world? So we've been working we've been thinking about different models. We've been working on a number of ideas. And what I wanted to share with you today is where we are at right now around data and the web. What I'm going to be discussing today, it's really a very early release. I'm actually really happy that we could get to do these kind of things in Microsoft these days. This is like so early as a technology. It's not even beta. We call it CTP because we don't have a name that means before CTP. And the main goal of this is we want to be very transparent in the process of how we think about these things. And we want to get feedback. We want to see, given these services and given this infrastructure, is this something useful? Is this something you would build on top? Is this something that will make your life easier? So take this as this is what we're thinking today. And we're waiting and really looking forward to get your feedback on the topic. And we can sort of exchange ideas and go together and see what is the right next iteration for this space of technologies. So let me start by making a brief problem statement, if you will, around what we are trying to solve. If you look at how web applications are built, it's funny. Like I tend to say were built before, and before is like 3 months ago or something. But it's like web pages that are part of a web application typically were made of a presentation information, like all of your markup in HTML or whatever. Some behavior, some JavaScript in the client to adjust, mostly just for interaction with the user and the presentation, and data. Data was just embedded inside the application, meaning typically your canonical web application will run your PHP or ASP.NET or Java, JSP script on the server side, will connect to a database, pull a bunch of information, then will do a rendering code that sort of turns data into tables or labels or whatever, and then send the whole page down to the client. And the model was fine. And then all of these technologies and all of these buzzwords came in, right? So now we have things like RIAs. It's like a new term, these rich interactive applications. We have Ajax all over the place. It's like you gotta have Ajax to be on the cool side of things or something. We have mashups, like all of these technologies that basically are changing the way you architect and organize your application. And in particular, they are having a very, very direct effect on how you interact with data. These applications, if you look at how they are built and how they interact between the client and the server part, they are introducing a very strong separation between the presentation information and the data that the system manages. If you look at an Ajax application, for example, usually what happens is you hit the web page. The web page will send the markup, like the HTML and pointers to images and so on, down to the client. It will also go with a bunch of JavaScript. and then the code in the page will turn back and interact with the server and pull data as the user interacts with the page. And this is actually the value add of this Ajax technology, is that you get all of this interactivity. You get to, page stays there, and as you interact with the UI, the code that is underneath that web page goes back and forth between the client and the server, fetching the information that you need or pushing information back to the server. In the case of rich interactive applications built with technologies such as Flash or Silverlight, this is even more so. Those applications are built into binaries. Like a Silverlight application is a DLL. There is no data that you can put there. I mean, sure, you can hard code something, but it's not that fun, right? Like, if you're building a real app, like, what's going to happen is you build your application. Application has a little bit or a lot of markup that's around the Silverlight app, but one way or the other, the app will go to the client, and the first thing you need, if you're a data-driven application, is you need to turn back to the server and get information to put in that user interface. So what's happening is all of these architectures are intrinsically pushing for a separation that is very strong between data and presentation. And this is funny, like in many other environments, this is something we've been looking for many years. If you look at everywhere from MVC to Java Model 2 to any other like reasonably nice architecture out there, one of the things that all of these models have very present and strongly encourage is separation between your presentation information, your behavior, and your data. It just so happens that these models have this as a more like intrinsic characteristic of the way things work. So it's nice. It just happened, but it's very nice. Now, the question now is, how do we help in this space as the team that builds data stuff? So shipping presentation is, from the server perspective, is mostly shipping static content. It is the client where the smarts are. This is where we're building, Silverlight, when we're building ASP.NET Ajax, and all of these technologies like Visual Studio integration with all that. So you can build really, really nice presentation tier components. But now the question is, how about the data? And sure, you can roll your own. This is like first instinct is a piece of cake. I'll hack up a quick script. You give me a parameter name or something in the query string. I'll render some XML, send it back to the client, and I'm done. And it is actually fairly easy to do. The problem with that is it doesn't scale from the development practice perspective. Like, what are you going to do with the next one? You roll another one, and then another one. And then no two of them has the same interface. Like one takes like a question mark, sorts something, and the other says, well, /sort, and the other has the sort in a header. So this not only means you don't get to reuse your own things, it also means that it's very hard to build other technologies on top that leverage the fact that there is uniform patterns around this thing. Like, for example, how would you build widgets that understand data automatically just by pointing them with a URL or something if you don't have two URIs that are the same or follow the same pattern? So I think that is where we can help. We sat down, we started to think about what do we build to enable this class of scenarios. And the first thing we did is we came up with a set of guiding principles, if you will. It's probably too much for this, but it's like this criteria that you keep in mind and you make sure that you go nail those aspects. There are a lot more detailed aspects, but these are the sort of the high order points that, in my opinion at least, are like what is going to make these services and this infrastructure actually usable in the real world. So first of all, if we want to provide any form of service for applications that you consume and push data back to any form of data service, it has to be just HTTP. The reason I say that is, so you can no longer assume that whatever piece of code you have has line of sight with the database. You most likely, the code that sits on the client has the whole internet in between, and then the firewalls and the proxies and the DMZ and who knows what more out there. So that model just doesn't work for this class of applications. So by just saying that all you can do is HTTP, what you're saying is you got your web page or you got your Silverlight DLL or something through an HTTP request. So if we just do HTTP for whatever is the way we deliver data, we're going to make it the same way down to the client. And we'll go through proxies. We'll use the same authentication information and model. Like the caching infrastructure that is already deployed at large in the internet is available to your service, and so on. Second, uniform patterns are key for this technology to be interesting. As I said before, you can roll your own, and this is actually not hard to do. I mean, just write XML, query a database, transform something, and send it to the client. The problem is, in order to sort of achieve better economies, what you want to do is say, I'm going to build my UI components as a library, and then my services in a way that, regardless of the particular application I'm building and the particular schema I'm using, like as a database schema, what I want is any of these components to work on any of these schemas by just following patterns. So I want, ideally, URIs that point to information and are the means to say what piece of information I'm talking to, and those URIs being in a format that can be leveraged and predicted by tools and libraries that then can use that to automatically give you services to wire up components and do presentation information. Then, so the next aspect is, I work in the SQL Server team. This is my data team. The team where I work on is part of the bigger SQL Server organization. And so we are kind of data nerds type of people, right? So we could have a never-ending discussion on philosophy and data formats. And the point is that, particularly in this model of interactions in the web and at the speed at which applications are being iterated over these days, this is not about formats. All we need is a way that is reasonably understood by both ends, where we can produce data on the client and the server and ship it to the client and the other way around. So we are being very careful on focusing on giving great data services, and formats are just a tool that we use to make sure that the different parts understand what we're building. Finally, when you're building tools that sit on top of stores, like say a relational database, it is very tempting and very easy to let the underlying like the characteristics of the underlying storage permeate all the way up into your services, and then all of a sudden you're doing HTTP to SQL straight to the database. And now life is not that good. Like you all of a sudden have foreign keys in HTTP URIs or something, or you take SQL in the query string, or things like this happen. So I think the trick here is to find an appropriate abstraction that is somewhere in between, that can play well with the database, but at the same time can present a view of the data that makes sense for those that are consuming the information, regardless of what is the actual mechanism you're using to persist that data on the system. So we took all that, we thought about that for a while, and we came up with a set of technologies. One of the first piece we are announcing here at MIX is a project called Codename Astoria. Marketing guys tell us that we have to say code name every time we say Astoria and even do the quotes. So Astoria is a mix. It's a set of patterns. It's a set of bits, meaning infrastructure, and a set of services that enable you to build services for the web. In Astoria, in this form, what you can do is you can go to the web. I'm going to point you to the website in a minute. You can download the toolkit and roll your own web data services as part of your web applications. Like right now, you can start trying it today. So this so far is like really hand-waving, very abstract. So let me show what a data service looks like. I'll do sort of a quick pass first, and then we can come back and drill down, see how you actually build one of these things, and how you can actually leverage in your own application. So let's start by doing a quick walkthrough. Let's just log in here, of what a web data service looks like. That is, of course, if I can log in into my own computer. Of course, this never happened before. How much time do you have? OK, we'll give it 15 seconds, and then we'll do something else. I'm sure we'll find something else to talk about. There you go. OK, there. So let me run this project. Later on, I'm going to actually build one so you don't get all of this bunch of files and you don't know what I did to get here and stuff. So I'm going to talk about this later. For now, let me hit Northwind. So I have a small project here, and I have Northwind that is almost the canonical example for a database, so I had to start with that. And when I hit the entry point to this data service, what I get is the list of containers, things that have instances of entities, and I'm going to define entities later on in my system. And what I can do now is I can start drilling down using URIs. So since this URI box here is kind of small, I have just a little wrapper that just makes it bigger. Let me go here and say large fonts. Hopefully this will do better. Let me actually make these fonts large as well. And I actually have to close this, so bear with me. Open again. OK, so let's hit the same thing again, make sure we're in the same place. So this is where we're just seeing before. So what I can do is, first thing I can say /customers. This probably you don't want to do in a real thing because it's going to list all of the customers. But still, it's a URI that represents all of the customers in my system. So what you get back, in this case, is encoded in XML. And essentially, it's a collection of customer entities. So I can see I have one here, and another here, and another here, and so on. And for each one of them, I have a set of properties that are defined for this customer in my system. And I'm going to talk about how these things come to exist in a minute. Let's take a look at a couple of aspects of the payload and how this interaction happens between the client and the server. First of all, you will notice that every entity has this URI attribute on the header or on the wrapper element. This is because every entity in Astoria, every unit of information has a URI. That means you can point to any part of your data system using a URI. Like in this case, for example, so there is an XML-based URI here to avoid repeating this in all over the document. So if you compose this with this, what you get is an URI. Let's copy this guy. I'm going to paste it here. This I didn't want. So this, for example, is the URI for this particular guy. And in this case, I didn't get a set. I get this one customer. So this is a URI that represents this one customer entity in my system. And you can also see that this customer has a set of primitive properties. These are like strings or integers or date times or things like that. And it also, in my model, and again, this is I'm going to get in a second. In my model, I said that I have customer things and I have order things, and they are associated with each other. And I said the association is called orders. So there is this orders member here that it doesn't look like a property. It looks like a resource. And what the semantics of this resource is, these are the orders or the sales orders for this particular customer. So here I can say /orders, following that property name. And this is the set of sales orders for this particular customer. Again, this is a URI that different agents can exchange or you can store somewhere. And of course, the actual output is dynamic. It's whatever are the orders for that customer at that particular point in time when you go fetch the query, the results of the URL. And this is going to the server through regular HTTP GET, right? So, which is the same way the web page got into the client in the first place. So if the page made it there, this is going to make it there as well. A few other things you can do with this. I'm using a shorthand syntax here that says, since I have a single expression there is no composite expression. This is assumed to be a literal, and is the primary key to the entity. I can also put a more elaborate expression. Like, for example, I could say, I want all of the customers that are in the city of London. And this will give me the subset of those customers that are where the city field, right here, is London. So this is a query. It's a URI that encodes a simple form of query. And you can do ands, ors, parentheses, the usual expression syntax around this. You can also keep drilling down. Like, for example, I could say, well, of those, I want the orders. And then you can keep drilling. You can say, well, I want a subset of orders that have some condition you will express here, and you can keep going. Like you can traverse the graph of associations that represents all of the data in your system, and you can keep sort of constraining and then navigating and reducing again and so on. Then, in addition to this is a simple URI format, right? And then you can build tools that leverage this. Now, most of the tools you will build for this tend to be UI tools that you will use in an Ajax or Silverlight application and things like that. And so there are a set of services that are interesting for those tools to have. Like, for example, every one of these applications will do, like a common example is you show the customer information, and let's say we're building an app on top of this. And you want to show the sales orders. And you know that when you're fetching the customer, the first thing you're going to do is go back and go fetch the orders for that customer. So you can actually tell the system, let's say you have a customer, it was Alki, I think, yeah. So you can say, I actually want the orders, just include them along with the customer. So what you get is, you get the customer just like before, but then instead of getting a resource for the order, what you get is the orders collection expanded in line underneath the customer. And you can do this, if you have several associations, you can do this for several of them. You can choose which ones you traverse into and which ones you don't. You can even say, go 2 or 3 levels deep into the association graph and so on. Another common need is, you may want to say, well, like I have a very long set, say customers, which is probably a large set, or even, let's take products. So this is, say, your product catalog, which tends to be long, and you don't want to bring all of them. So what you can say is, well, I'm doing products, so I want to see them sorted by product name. You can imagine clicking on the column in a grid object or something. And then you can say, well, of those, give me the top 10. Or let's do the top 2 so you can see it. And then you get only 2. And there is also a skip clause that you can add here, which effectively enables paging. You can say, skip 20, give me 10. And that's effectively the third page of 10 row pages. So now, the nice thing about this is that all of these patterns are very uniform regardless of what is the underlying store. Like, so far I've been using Northwind. I can switch, and for example, the Encarta guys, they are also a Microsoft product, they let me borrow their database, the Encarta article base. So what I did is, now I have a model on top of Encarta, and what I have here is Encarta in pure data form, like there is no user interface. So for example, I can say /areas, and these are the areas of content of Encarta, like I have religion and philosophy, science, and whatever. And I can drill down on one of them. I can say sub2, because I can say here that that's the primary key, and this is that area, and there is an association, so I can say /articles. And these are going to be all of the articles in Encarta in the section of science and something. And I can even pick one and see related articles, because I see that there is an association there saying related articles. So I can grab one article and say /related, and I'm going to get a list of articles related to this article. Again, the important thing is that regardless of which particular schema, the patterns are all the same, which enables building infrastructure on top of this, which includes UI elements, it includes client-side libraries, and so on. Let me switch back to here for a second, and I'll get back to this in a moment. OK, so Astoria is the thing that lets you build these services. What are the main characteristics of Astoria? So first of all, it heavily depends on having a higher level model. When I say that I have a customer, what do I mean? What is that unit of information? Or when do I say that a customer has orders or an article has related articles? How do I know that? So what we do is we build this view of the database, this HTTP sort of access point to the database, using a model called the entity data model. Entity data model is an ER, or entity relationship model derivative, and it's a way of sort of formalizing what are your units of information. We call each of the entity structures in the system an entity type. And you can tell what types are in the system, what are the members of those types, what is the data type for them. And the EDM also defines associations, which is the other key element. Once you have entity types, you can also describe how the various types relate to each other. So you can say a customer is something that has orders, and an order is something that has an employee object that created that order, and it has order detail lines that are the lines for that order, and so on. So you can describe this whole system in very, very high-level terms. And then you can build services on top. That's the great thing about having a formalization of a model, is that then things can leverage the semantics that are that are captured in that model. In this case, Astoria takes that, and it brings semantics to URIs and payload formats that are brought in by reading the information in the entity data model schema for a particular store. Second thing, as I walk through in detail, we do a lot about having a uniform URI format. The goal of that is to enable building client-side tools, front-end like UI widgets and so on, that can leverage the fact that regardless of which particular store you're hitting, you can always know the patterns. You get, as you saw, you get things like sorting and filtering and association traversal and paging. So all of these services that you always have to build on and on again every time you build any entry point that brings data into your system. So these are just built. They are integral parts of the system. And finally, as I said before, we didn't get very philosophical about formats. We have 3 formats supported today. We support the plain XML format that I've been using so far. This is a trivial one-to-one mapping from the entity definitions into XML. We also support experimentally, even more experimentally than the rest of the CTP. We support this. We support RDF, the resource description framework. It's kind of early, but I'm very curious to know, folks that are into the space of RDF, what are the thoughts about this, whether it is interesting to explore this space, and so on. The third format that we support is JSON. JSON is the JavaScript object notation. Are folks familiar with JSON? Well, quite a bit. So JSON is a form of encoding data that uses a subset of the JavaScript syntax. And it's handy for environments where your coding language is JavaScript, because once you get a response back, you can eval the result. Eval is like the way in JavaScript to interpret JavaScript code. And bang, you get objects back. Like, for example, if we go to this that we're just using, let's take a smaller entity. Like, I'm going to take on categories, which are, since it is a smaller entity, it's easier to read. So this is a category in Northwind. It's a product category in the XML form. If I switch to the JSON form, it's not going to be all fancy colors because AI doesn't do that for JSON. But you can see that it's JavaScript-ish. There are braces and semicolons and stuff. It's a very simple encoding. It's not nice to read. XML is probably easier to read, especially with all of these tools that are now for XML. But it's very easy to consume from a JavaScript environment. And it also fits very nicely into the various Ajax libraries out there, like Microsoft's library or libraries like Dojo or any other library. They have direct support for hitting an HTTP endpoint and then get JSON payloads back and turning them into objects. So far we talked about how to retrieve information, and in particular we talked about the trivial case where you retrieve information and you are given sort of flat open access to the store. In practice, life is not that easy. So first, sometimes, depending on the nature of the application and also depending on which part of your store you're talking about, you want more semantics on top of just the raw access to the data. So if you look at even schemas on on sophisticated applications, you can see that there is a set of tables or a set of information there that really does not have a lot of semantics to it. It's just like product categories. You just create one or delete one. There is a security aspect to it to see who can do it. But other than that, maybe there are not that many deep semantics. Now, there are other parts of your system where you cannot afford to just touch the data. There are lots of business rules you want to run. There is behaviors that you want to make sure they are maintained. There's check-ins that you want to do. So Astoria supports this in a number of ways. One of them is you can define, in addition to just defining URIs, the way I've been doing so far, you can also define what we call service operations. And this comes from the fact that every Astoria service is essentially a WCF, a Windows Communication Foundation service. So by default, we create this special form of service that just serves URIs for you and gets the data back. But you can extend it with regular service operations where you can put more heavy business logic. So you can choose to say, for example, I don't allow people to say /customers and access flat all of my customers, but I do allow people to say /my customers. And I run logic in the server to build a query that defines what that is. Or like in this example in the slide, I could say customers by state and pass an argument that is the state. So the other aspect of this is how about, this is fetching data, which is not very useful in isolation. Like how about pushing data back to the database? Well, we do the same thing. We have a data service. You never see the database. What you interact with is an HTTP endpoint. And what we do is we support just the regular HTTP verbs. You can do post to create things. You can do put to replace things in the store. And you can do delete in the HTTP delete to delete something from the store. So semantics are very simple, are sort of resource-centric semantics. And again, you can enable this or you can disable if you don't want updates on a particular point of the system. And you can also run interception code there. You may want to say, yeah, I don't want you to just go create any random entity with any random set of values and just do a HTTP post and create something. I want to run code when you're just about to push that into the database system and validate that I like what you're trying to push in there. So let's create one of these things from scratch and see what it looks like from the VS experience perspective. For that, I'm going to use just a brand new project. I'm using Visual Studio Orcas Beta 1. And I'm going to create a web application. And the goal is, I'm not going to build, for this part at least, the user interface. Let's just build a service from scratch. So first thing I need to do is tell the system which database I'm going to work with and what is the schema information for that database. We talked about the EDM before. I need an entity data model definition of this schema. I could choose to go and model my schema first and then figure out a database. Or in this case, I already know which database I want. So what I want is the system to look at that database and automatically generate an EDM schema for me that is mapped one-to-one to the database. Then you can tweak the mapping and adjust how things look like. So I'll go to application, say add new item. And I'm going to choose ADO.NET entity data model. We're going to go against Northwind, so I'm going to say Northwind here. And then a wizard will come up that will say, first is whether I want to create one from scratch. In this case, I want to generate a model from a database. Then I have to choose which database I want to talk to. In this case, I already have a connection. It's called Northwind. Remember this name. This is the name that the system will use to refer to the database as a whole. We call this the container name. And now the system goes to the database, retrieves fetches the metadata, and in this case, which tables are available in the database. I'm going to just leave the default. And when I click Finish, the system will go to the database, fetch metadata information, and produce a default EDM schema and a mapping for me. The output is a bunch of XML files you can see here, and you can have a lot of fun looking at them. Usually, you don't need to, and it's much nicer if you don't. Your life is easier and everything. We also, to save you some pain there, the other thing we do is we generate CLR types for every entity type. And we also generate proper navigation properties and collections for relationships and so on, so that you get a nice .NET-based object model for your EDM model. So now I have a model. Next thing I need to do is create the actual data service. So I'm going to go add new item. And I'll point to a web data service. And I'm going to call this Northwind as well. So this gives us a very simple template. And we need to do only one thing here. Let's import the namespace. So when we generated the model, we generated all of these types. And they are all under Northwind and then the word model for this particular namespace. And here is where I want to say against which container I want to run this data service, which in this case was Northwind entities, which was what we had to remember. And we're done. Now if I hit F5, I'm going to have a data service that is up and running and ready for, then I can add web pages that have, Silverlight code or Ajax code that they can already go back and hit this service. Like here, this was northwind.svc, which is the WCF extension for services. And if I hit this is the content of the database, and I can say, just like before, /customers or /something, and I'll get the information in that. So at this point, I'm done creating the data service. So this is a very quick way of getting you up and running. Then, of course, you have to do some work to harden this, close the parts that you don't want open. There is a way of putting policies in place and so on. Let me, real quick, just give you one example of one of the ways you can incorporate business logic into this thing. We talked about saying, maybe I don't want all of the customers to be accessible just directly, either because I don't want a scan in the database to kick off and scan all of my records, or because maybe you expose records or entities based on who you are from the authentication perspective and so on. So here's a simple example. Let's say I want to access customers only by city. So I'm going to create a new method. I'm going to add the WCF attribute webGet that says this is a HTTP-enabled entry point. And what I want to do here is create a special form of service operation that is data-aware. So the problem is, if I just do a regular RPC-style call here that takes parameters and returns a fixed result, then all of these nice things I was talking about before, like being able to sort and query and so on, they're all gone, right? Because now the interaction is fixed. So what I can do is I can still preserve that by using a special form of service operation. So I'm going to create one. And the key is that instead of returning results already baked, I'm going to return a query object that the system can then further compose on top and execute before returning to the client. So this is going to be called object query. I want to return customers, and the system already generated types for me. Let's call these customers by city. And the first argument is provided by the system, and it represents the session with the EDM schema and then to the database after that. And I'm going to take one custom parameter, that is the city. So now, let's say we'll put business logic here. Let's say the business logic is city can't be null, and city has to be more than 2 characters. So if none of these conditions met, we will say throw new exception, but city. So and now, let's say our business logic passed, and we want to build a query. So here I'm using the entity framework on the server side to build a query that then is going to be executed and sent to the client. So I'll say return database dot, and again, I have typing for this stuff. We generated all of the metadata based, turned into .NET objects. I'll say .where, and in this case, I want to say where the city is the @city parameter, and I'm going to bind the parameter to the parameter was called city, and the variable is the argument city. So, and that's it. Now, if I build this and go back to the browser, what I can do is, of course, I can disable access to /customers alone, and I can say customers by city, and then say $city equals London, for example. And so this is going to list all of the customers that are in the city of London. But the cool thing is that I didn't lose the rest of the stuff. I can still say, by the way, do top 2, just give me the first 2. Or by the way, sort this by this criteria. So all of these components that were leveraged in this URI syntax, they still get it. But they are doing a service operation. So you land in this very nice spot between raw access, which is not practical, and RPC access that is you get full control, but then you get 0 flexibility. This is finds a sweet spot right in between these two. So now that we have established that we have this read-write story and we have this uniform pattern, let's look at some of the things you can build. Like the ASP.NET folks were nice enough to build some UI controls on top of this, so we can play the end-to-end and see what it looks like. And so I have this set of Ajax components. I want this other guy. So this is basically, it's a grid object, and all you tell the grid is, for example, you're going to work with /customers. And that's all the specification. Now the grid knows how to do sorting over this, how to do paging, how to turn into write mode and write something and push it back to the database, and all of that by just saying /customers. In this example, I have is the grid is put there, and then there are a few controls so I can manipulate the thing. So for example, we'll point this to Northwind, the same service we were using before. And now I can go to customers, see the customers. I can sort them by contact name, pick one, then see the details, click edit. I'm in edit mode now. I can go here, see the orders for this particular customer. I can walk back to the customer or to all of them. There is one line of code here, right? /customers, right? And sorting, querying, read, write, everything. And just like I was working in Northwind, I can say /Encarta, and bang. These are the areas for Encarta, and these are the articles that are in the, I forgot the category name. I think it was art or something. So, and again, read, write, I can see related articles that are, of course, I picked the one that has no related articles. You can see articles related to this one and so on. So, and as I said before, let me see, this is the Northwind service, which is right here. Let me copy the service I created in the new project. I'm going to have to tweak it just a little bit. Put it here. And this is customer because I tweaked the mapping a little bit. I think that's about it. Let's see if this compiles. And let's go back here and hit Northwind again. So if I go to customers, I get all of them. But I can now say customers by city, question mark, city equals London. And these are the customers in London. And I can still sort. It's like, this is what I was talking about before. And the grid figures that out because it just composes the query. So this is the value of these uniform patterns working together in this data service and in the front-end tier. Thanks. Thank you. All right. So now we sort of mentioned what is our problem statement. We went all the way down to technology and details. Now let me circle back up and go to what scenarios are we actually solving? What are the problems we think we're solving and how? First scenario is Ajax applications. Every new application, if you want to be cool, you have to use Ajax for whatever reason, right? So if you look at how Ajax frameworks work, even if you're doing this by hand, but most likely if you use a framework, HTTP plus a JSON payload as an exchange format happens to work very, very well. So the way you build this is you write your HTML page, send it to the client, and then on the client, you have some JavaScript code that can go back to a server and retrieve the information. So let me build this scenario because it's a very important one, and I want to walk through the details. So let's type a little bit of JavaScript and see what this looks like. How many of you are actually building Ajax applications today? Wow, a lot. So let's come here. I'm going to go to this page that I already prepped. So here's an interesting first problem. So I have this page. Let me run it so you can see what it looks like. So it hits the Encarta database and lists the areas. And then now if I click in one, I get an error. But that's the part we have to implement. Now, first question is, I know that I'm going to draw the areas there. So I don't want another HTTP request only for that. That one I want to render on the server. But then the rest I want to render on the client. But I don't want two models to do this, right? So what I'm going to do here is I already generated the EDM schema and the CLR types that correspond to this. This was the step that we created the data service. So if I go here, you can see that the way I'm rendering the area list is I have a data list object, and I'm using, this is an ASP.NET regular data binding control. And every URL has a call to the list titles and puts the ID. And the code behind the page that populates this data is, in this case, C# could have been VB, running on ASP.NET. This is server-side code. So this code says, connect to the Encarta database, fetch all of the areas, and bind them to the source. Look at this code. I mean, no connection strings, no configuration, no quotes, this is like pure intention from the user, right? This is exactly the intent of the guy that was writing this piece of code. So, and what this means is now when you hit the page, you get areas back. So now that we have the areas, we have to write the code so that when you click on an area, we want to fetch the title articles for that particular area. So let's go to the web part of this app. And so this calls a function called list titles. So let's implement that function in JavaScript. And I'm going to use the Microsoft ASP.NET Ajax framework. You know, I work there, they're friends and everything. But you could use, Dojo or any other framework, and it will do just fine. In this case, I'll say function list titles. This takes the ID, which is the ID of the area I'm looking for. And so what do we want to do here? First, we want to connect back to this HTTP endpoint that represents the service. So I'm going to create a request, say new. Look at this. It has nothing to do with what I'm talking about. But this is IntelliSense in JavaScript over the Microsoft Ajax library. I go like sys.net.web. It's great. You don't have to remember the stuff in the browser either now. So now I have my request. I need to point it to some URI. So I'll say set, set URI or URL. And so my service entry point was Encarta.svc. And then what do I want? I want the article entities for this particular area. So I'm going to say areas, bracket, ID, bracket, articles. And that's my query. Right? That's a URL I want to go fetch, my resource. So the answer, I want it encoded in JSON. So I'm going to say get headers, sub accept, which is the standard HTTP header to say which is the type you expect on the way back. And I'm going to say application/JSON, which again is the way systems say that they want JSON. Last thing I need to do is, like the A in Ajax is about asynchronous, right? The deal here is I want to kick off the request and then free up the thread so the user can interact with the system or with the browser. And then when the request is completed, I want to be called back so I can do the rendering. So I'm going to add a callback. I'll say completed is titles completed, which is a function I'm going to define in a second. So last thing I need to do is kick off the request. So at this point, I call invoke, the request is running. When the request finishes, this callback will be called, and a response object is passed back to the client, or the function. So first thing I need to do is make sure things went well. So I'm going to say response.get status code. If it is not 200, which is HTTP OK, then something went wrong. So we can go alert wrong. And maybe say why. We'll say response, get response data. Else, things went well. So what we need to do here is render the contents, basically render the list of titles. What we got back is objects because it was JSON. So I'm going to declare an array, a variable that is going to be just the articles, an array of article objects. And this is equal response.getObject, which will automatically turn my response into JavaScript objects. Now, what I want to say is I want to build a list, like an LI list of list items. And for that, I'm going to use a string builder. So I'll say HTML equals new sys.stringbuilder, which is also a Microsoft Ajax class. And I'm going to start with an unsorted list. And then I'll say for var I equals 0, while I is less than arts.length, I++. And for each one of them, I'm going to say append. We'll append the line item. And then art sub I, it's a article object. So I'm going to say dot title, no quotes or anything. And finally, I'm going to close the line item. And to finish the block, I need to close the unsorted list tag. So I'm going to say /unsorted list. Now that we're done, we need to put this somewhere. So I have a div already here called article titles. I'm going to put the list right there. So I'll say get titles dot inner HTML equals HTML.toString. And hit F5, come here. This will take a second. So now when I click on one of these, OK, no issue. Hold on. This is, I already went through this. Let's try again. We even have this in the README for the CTP and everything. Now I click on this thing. This goes back to a server and then brings the list of articles, in this case, to the client. and I can click on art and literature, and I get this one, or I can get in sports and get this one. The page is, of course, staying on the client. I'm just going to the server, fetch the data, and bring it down to the client. The nice thing is I'm getting these super nice JavaScript objects that have the title and the description and the URI. So I can get a little bit fancier with the rendering. I'm not going to keep typing in front of you, so you're going to go to sleep. So I have a pre-built render title row. And this is nice. Like, your own functions within your JavaScript library now can use objects as contracts, which are the same entities on the client and in the server. These JavaScript objects are the same shape of your server entities. So the argument to render title row is going to be the arts of I, which is an article object. So now when I hit F5 here, all this does is this uses the summary property that is also in the object. So now I can hit on one, and as I hover, I can see the preview that says what the article is about, and I can also click here, and this will go connect me to the Encarta website and show whatever article I just picked. And I don't have the world thingy here, so probably it's not going to connect. So this is a very quick way of building applications that are very rich. I mean, you can tell that user interface is not my thing. But besides that, you can build very rich applications. And I didn't type a single line of code to support the data service, other than the added services that I wanted for business logic in particular. So there's no infrastructure code in place. OK, next scenario. So rich internet applications, or rich interactive applications, I guess is the marketing term. So Silverlight is a typical example of this. There are other technologies out there that are similar. The thing with these applications is, as I said before, data cannot come with a binary. It has to come out of band. So the way we envision this, and this is not in the CTP bits, but we'll get there pretty soon. The way we see this is you're writing .NET code inside Silverlight, and we have this client library, and I'm going to show it today in a full-on application, but this will also run in Silverlight. And we have a very nice, very simple to use .NET object model that sits on top of the HTTP requests and response. So you use a very simple .NET API, but you're still connecting to a server over HTTP, and you're still interacting in terms that are very web-friendly. So this is the second scenario. Now, these scenarios assume that you're serving the application and the data. Now, what if you you're not serving the application? What if what you're serving is something that doesn't have a server side for presentation? Like an example is, what if you have a desktop application or a media center application or something that needs to be desktop, but you still want to connect over HTTP with your data services somewhere on the web? So the second part of the Astoria project that we're announcing at MIX is something that we call the Astoria Data Service. This is an experimental thing. We're trying to learn, see how these things work. We want to learn what is appropriate model for a data service that lives just out there, whatever that means. In this case, it actually means in live.com, but it's just out there. So the Astoria Online Service is, again, experimental. I can't say that enough times. And part of being experimental is, these services have something called the SLA, or Service Level Agreement. So the one we have for this one is that there is no SLA. So it will work most of the time. If you take it down, send me an email. I'll bring it back up, and we'll go from there. So since it's tricky to use the service out there and start from scratch, we also uploaded a set of sample data services that you can hit right now and use. They are read-only. Otherwise, everybody will party on everybody's data, and it will be pretty messy. So we put up there Encarta, the article base I just showed. We put Northwind, because you have to have Northwind. We put AdventureWorks, which is an example that ships with SQL Server 2005. And we also put TagSpace, which is great. TagSpace is, so there's a site called TagSpace in Microsoft. I have a link at the end of the presentation that is a social bookmarking site for Microsoft sites. And so there are tags, and there are bookmarks, and there are the actual links. So you have raw access to the actual data that supports that. So you can go browse what people bookmark. Of course, there is no user information. We stripped that out. But you can see which tags are out there, which items correspond to those tags. So let's actually play with that. And just for the effect, I'm going to play with that from the Polygon computer that doesn't have, I didn't put a single byte on it other than the presentation. So I'm going to go to astoria.mslivelabs.com. which is the entry point to the Astoria website, to the Astoria service in general. And here you can read about the stuff. We have the usual documentation. We have examples. We have an overview document that is more on the philosophical side. We have a reference document that you will never read in a single shot, but it's nice to have all of the formats and everything. And then we have the online service. Let me go there. So I'm going to take tag space. You have to agree to something. You're supposed to read all that before you click I agree. I agreed before. So I can hit tag space now, right? And let me make font bigger. So this is the entity sets in tag space. I mean, the containers for entities are the tags, the tag items, meaning the actual links, and user bookmarks. So I can, for example, say, well, I want the tags, so /tags, and maybe I don't want all of them, so I'm going to say, give me just the top 10 tags. So I get tags. And these are each one of the tags and what they map to. Of course, I can pick a particular one. I could say /Microsoft, and I get the Microsoft tag in there. Or I can say, for example, AD.NET, which I have kind of an emotional attachment to. And this is the AD.NET tag. And you can see here that there is an association that points me to tagged items. So I can say /tagged items. And these are the tagged items, that is the links that are tagged with AD.NET as a tag. The expressiveness of the URI stays the same. I know this is kind of small, but for the effect, I'm doing this in the podium box. So, so same thing with like expansion of the details. Like I have another association here that is the bookmarks for this particular link. So I could say, well, I want, for the AD.NET category or tag name, I want all of the links, and I want to know who bookmarked that for each one of them. But I want everything together. So instead of doing /something, what I'm going to say is expand the user bookmark for me. And now what I have is all of the tags, all of the items in the AD.NET tag and its bookmarks, like you can see here. And this is online. You can, if you have your laptop open, you can like hit this now and do the same thing. And just like there is in tag space, there is Encarta, so you can go Encarta/arias. Whoa, wrong URL. Encarta.rsc/arias. One more. Encarta. I come up with funky URLs, and now I have to deal with them. There. And again, this is all of the articles for Encarta. We talked about before about business logic and not wanting to do certain things. Like Encarta is made of arias, then the articles, which is actually the header of the article, and then the actual text. So the text, since this is XML, in the server, I have to re-encode the text and send it over the wire. So if I let you do /article bodies, you will just, the server will be encoding all day long. So you can't say /article bodies. If you try, it doesn't work. Now, like you get an access denied. But what you can do is, let's say you pick on an article. Let's say articles, and then I'm going to say title, EQ. I think there is one that is like airplane. Let's see if I remember this right. OK, so I can grab the key to this guy, which is this number here. And as you can see here, you get the summary, but you don't get the actual article. So I can say get article body, and then ID equals this thing. And what this returns is the actual body. But again, you cannot do a scan over this. You can ask for one. And you can then go and ask for another one and so on. But then we don't do it today, but you could do throttling by request or something. So it's a more reasonable way of interacting with your data. I could even validate. This is a subset of Encarta that is open for everybody. There is a broader set of articles that you have to pay for. I could even validate here, and I could say, if you are authenticated, I let you call this many articles. If you are not authenticated, you get to call this subset of them. And I could have this business logic in that entry point. Oh, actually, I'm already in this box. OK, so 2 last scenarios. So now that we have this thing just out there in the cloud, one thing you can imagine is we're not doing this today. I forgot the last line from here. Let's say soon. So today, what we have is we're posting these read-only examples, and you can use URIs and everything with them. Very soon, you will be able to go to astoria.mslivelabs.com, describe in a simple user interface, nothing too fancy. You will be able to describe the shape of your schema, click a button, will provision storage for you. right? This is an experimental deal. We'll see how it goes. But basically, you get a URI, which is your very own. You get a set of credentials you use to log in into a thing, and you get about 100 megs or so. So this is not a blob store for pictures or something. So I know that you're supposed to say like, you get 100 gigs or something. But we're going to go with 100 megs. It's structured data or semi-structured data. And then these things start to make sense. If you look at what happens today is when you roll something like a mashup, you have two options. If you host the mashup yourself, then sure, on the back end, you can put whatever you want through your own mechanism to store state. Now, if you're doing something that is entirely on the client and you're grabbing RSS feeds and or maps or things like that from everywhere, it is effectively a stateless application. You put everything, you paint a super nice thing, and now you click the browser and the whole state is gone. What if I want to say, canonical mashup is you put a map and then you put dots on it. That means something. So let's say you have that. And on top of the dots, I want to add my comments, which are different from your comments and different from your comments, right? And then I want to share comments between people and stuff. So where do you put that state? And then once you put it there, how do you get it back? Well, these services enable these kind of scenarios where the data itself is out there in the cloud. The other scenario is the one I hinted at before, and this is the last one, where what you have is you have a desktop application. And you have your reasons for having a desktop application. There are many reasons for that. But you still want this. This is an internet-enabled application, meaning that this is the client part of a software/service deal. So the question now is how you access the server. Of course, we have, for example, in the .NET framework, we have HTTP client classes. The WCF team is rolling very, very nice API for REST or HTTP-based services out there, which is a general purpose API. But what if you know that the other end is an Astoria service and you want to leverage that? So what you can do is you can build client-side apps that are very rich and still interact with the Astoria service. So I have this example that, I was mentioning this last session I did on this topic. I've worked in the database systems for a few years now. So I'm not even a server guy. I'm the server guy. I'm not even in the middle tier. So user interface, not my thing. And this event is always so cool and stuff that I had this friend that actually built a blend application for me. So I don't have to look here all lame because I have just console apps or something. So I have this thing. I know two keys. I know if I hit tab, I see the whole application. And I know that if I hit F5, the thing runs. And then I know how to do the coding part. That's easy. But these circles, really modern thing. So what I have here is a blend app, which is essentially this is a XAML designer. So what I get in the end is a VS project. And I'm not going to change my password now. So first thing, this is an Encarta front end for the same service we looked at before. So let's say first thing we need to do is fill up the combo box that lists all of the areas. So look at this code. So basically what you do is you can write your own CLR types if you want, or you can use a tool. We have a tool that you point to the HTTP entry point of the system, of the service, and we generate client types for you. So you got a nice object model that represents the entities on the client side. If you don't like our types, you can roll your own types. And the requirements for your own types for the contract is precisely 0. The properties you like, you put them there. If you don't want a property, just don't put it. And we will map the ones that match, and the ones that don't match, you have a knob that says either we fail or we ignore them. So in this case, I'm going to create a web data context, and the argument is the URL of the service. And then I'll create a query, and my query is /arias. That's all I want. And then this gives me aria objects, so I can dot and say .name, and that's what I'm adding to the combo box. So let's run this thing, hit F5. So this is the app. So first thing I need to do is get the URI to the service, which was this guy here. Put it here, /encarta.svc, click connect. It takes a second. So this went over HTTP, and he got the areas and then picked the first area. So I can go here and say, I want this one, and these are the physical science, whatever, or these are the art ones. And each one of them is an HTTP interaction between the client and the server. I can even say, in this case, this application, it's a desktop app, and it's read-write. So I can push information back. You can go here and say, pick your favorite thing. You can see here the summaries of what each one of these things is. And you can go here, like, arsenic. Here you can say, do not drink this. And click add. And this now goes, this is in the server now. That's an HTTP post and puts the payload on the server. And now this is part of the database. If I go off and then go back in, this thing stays there. And if you query using some query tool, you will see it you will see the record in the underlying database. So this enables the client-side scenario for this in a very rich way, and the EDM semantics are preserved. Let me give you one last example of this. If I go here, I just added this note object. Let's look at the code that takes to add a note. This is the handler that runs when you click add note. So what I do is I grab the article object. Again, this is just everything works in CLR temps at this point. And I create a new note, set the text. This is winding up an association. I'm saying note.article equals this article object. And the system will figure out what that means in HTTP terms. And then add the note to the notes collection and click Save Changes. This guy does an HTTP request and pushes the thing down to the server. Again, this will go if I have a proxy in between, or I have HTTP authentication, or I have whatever that sits in between. If I could do a post in the browser, you can do a post here. So it's very, very straightforward way of building client applications that also leverage internet services out there. All right. So wrapping up, so regarding the roadmap, where we are now is, as I said at the beginning of the talk, this is a very early CTP. We're very, very much looking for feedback. I'm really curious to know what you think. I'll be hanging out in the Mix chat, but also, we have blogs and emails and things. Like, just do come talk to us, give us your thoughts, your opinions, what works, what doesn't, and so on. We will probably iterate again towards the end of the year, very likely. There are clearly a number of topics I didn't touch on here. Some of them you can go to the site and read our current thinking about them. Some of them there's nothing to read. Things like I didn't talk about authentication, and in particular, how do you authenticate the owner of the data, the developer of the data? There is a whole problem there that is, I think, is beyond technology. It's like there is some space that needs to be solved, and it's bigger than Astoria. This is like a new problem out there that we have to go tackle. Search engine optimization, like how do you make, you have this data, now the application doesn't have anything interesting to search in the UI. The searching thing happens in the data, so what do we do about that? And things like synchronization. Do you want to synchronize maybe the content and use it online or something? Or should we do RSS or Atom for feed formats? So all of these questions are up there, and we're actively working on figuring out what are the right answers. And it will be great to hear what you think about all of these. When you get the deck is available, you can get the resources where there is the website that I showed with all of the services. So you'll get all of this with the slide deck. And I want to thank first the guys that let us use the data, the guys from Encarta and TagSpace that we could borrow the data from them, which I think is a fun exercise. You can go out there and play with Encarta, play with TagSpace, and so on. And so with that, please fill up your evaluations. And I want to thank you very much for coming today. It's the last session, so I appreciate sticking till the end. Thanks. Thank you. I can take a few questions now, and I'll be hanging out in the Mix chat later, so I can also take questions there. I think there's beer there, so you do whatever you want. I will come back to my resources slide. There you go.
Hi, Pablo.
Hi.
Going back to the beginning of the presentation, when you started doing the demos in the browser, the queries in the browser, it sort of was a flashback to demos from 5 years ago when people were demoing using the SQL Server web service to SQL the database.
Yeah.
Can you compare and contrast what's different now?
So there are actually a couple of technologies that are, we borrow a lot and we share a lot. One is the SQL Server SOAP support, which I think is what you were referring to, and the other is SQL XML. Which is like a more middle-tier technology rather than a server-side technology. Let me take on both of them. So the first one, the one you talked about, I think this is a different beast. This is a middle-tier system. It does share in common the fact that this shares data over HTTP, this principle is there. But this is designed from scratch to be a web thing, whereas that one service was more of an interop story. So I think the key difference is what is the scenarios you're going for. This is very, very focused on, we understand this is going to be web-facing. whereas I wouldn't put web server, my SQL server on the web, even on port 80. That's more of an interoperability story, more of a way of reaching the server without having to have a TDS client. You could do SOAP and things like that. There's also I don't use the word REST too much, but there's a REST thing to it that wasn't there in SQL. That's from the SOAP perspective. Now, regarding the SQL XML story, we borrowed a lot from SQL XML. Many folks from the SQL XML team are in my team now, like Andy Conrad, which is a known blogger. He works in the ADO.NET team. He built and tested part of SQL XML, and now he works on Jasper, a project that is sort of close friend of this one. So we talk a lot, and we exchange a lot of ideas. We try to learn from the mistakes and capitalize on good ideas.
All right, thanks.
Thanks.
Hello, question about field level granularity. So
Okay.
you showed us actually going down to record levels of collections.
Yes.
But can you go to a specific, like the description field and do a put operation against that with Astoria?
That's a good question. So you can't in the current CTP, but I guess I'll turn the question back and it's like, should we? Should we add like I had this one scenario, let me tell you this. I had this scenario where like one of the fields was a picture. So I wanted to put an image, then say source equals the picture. So I hacked that up just to do that, but then it was a hack, so it's not something I could ship in the CTP because I did it really quick. But if there are scenarios and you think that's interesting, then we could do that in a serious way, not a hack, and keep it as a feature for the system.
The scenario that comes to mind is that you have a database record and you want to update a specific field in the record, but with the current put semantics that you were showing us, you're going to upload the whole record again.
Yes.
And sometimes that record might be huge.
Okay, so actually, I didn't show that because I can only speak so long before they kick me out of here. But actually, you don't need to send the whole record back. Like you can fetch a record, and then when you do an HTTP put, which is an update semantically, you can skip fields you don't want to change. Like fields that are not in the payload are not touched. Like to mean null, you have to include the field and use null.
That
if you
makes
want
sense,
to just not touch it, you just don't put the field in the payload, and it will only touch the fields you actually send in the payload. So you can do that today.
Okay, excellent. Thank you.
Thanks.
So we're really excited about trying this out on an internal app. You mentioned that the security is still kind of a problem. Where is the security right now? Is it sort of not
question.
there? Or?
So if you're going to try it yourself, you probably get quite far with it because so what we do is from the authentication perspective, when you're running not in our service but in your own application, we just use the ASP.NET authentication scheme. So if you have an authentication story, we'll just use it. Now, from the authorization perspective, so today the thing is very coarse. Like we have essentially a policy that says for each entity set, you can say whether it is visible and whether it is writable in one axis, and the other axis is you can say whether this happens for anonymous or authenticated users. So for example, you could say this entity set is read-only for anonymous users and read-writes for authenticated users. Or you could say you cannot see this data unless you're authenticated. But it doesn't have principal granularity. So it's not like you can say these guys can see, these guys can update. Honestly, this is a space that needs enough exploration that our take on that was let's put something so you can get started, and then I'd love to hear what was missing. And what is when you're typing the thing, what would be nice to have in order to have nice integration of the security model with the rest of your application.
Great. Well,
So yeah, you have some pieces today.
You'll get our 2 cents in about 2 months. So.
Sounds great.
So I have another technology comparison question.
Okay.
So I noticed in one point you did the server-to-server call when you were doing the initial data binding from ASP.NET.
Yeah.
And that's sort of the place you normally see them using ADO.NET and data sets and that kind of thing,
Yes.
and kind of doing a SOAP call or something like that. And do you see this as kind of replacing that in some scenarios for server-to-server calls, or do you see this mostly as client-server calls?
Good question. So what I was using there is the ADO.NET Entity Framework. This is a new technology for data access that is it's an extension to ADO.NET that introduces sort of support for objects and support for modeling and things like that. It has some nice things like the fact that you have an underlying model you can leverage, and it has all of this strong typing thing that is along the lines of what typed data sets or table adapters used to do, but with the flexibility of doing arbitrary queries that you can build on the spot. I just said .arias on that example, but I could have written a link query that says, from A in arias, order by aria name or something, and then select A or something like that. So it's It's a different way of doing things. It's a connected way of doing things compared to dataset, which actually works really well for this kind of ASP.NET apps, where you're going to lose the state anyways a millisecond later. So there's no point on caching it in an intermediate thing unless you're actually going to do something fancier to cache it. Like in this case, this is probably the best way of doing it. We fully support the dataset, and I think there is a class of scenarios where that is useful. But this is new technology, and this comes to address some of the pain points of dataset and some new scenarios that weren't there properly handled by dataset.
Perhaps I missed from the beginning. Is there going to be support for different databases? And the second one, are there any plans to support additional objects like store procedures, functions, or views?
So first question is if there is support for other databases other than SQL Server. So yes, absolutely. This is built, so Astoria builds on top of the ADO.NET Entity Framework, and the Entity Framework has this very nice provider model where you can plug other providers. And we have a number of vendors that are already working on revving their providers so they work with the new version of ADO.NET and the Entity Framework. So you can just throw in a provider to any other of the databases that are out there, and you get these services on top of their database. Of course, I have this emotional attachment to SQL Server, so I like it better. But yeah, it will work with other databases as well. Regarding the objects, there are two ways into getting into Astoria services. One is the URI syntax. And that requires us to generate queries on the fly, basically, which means that requires dynamic SQL. Now, for the case where what you want is these service operations that then go hit, like RPC style, hit the system, the middle tier system, then there I wrote a query in my code, but I could have written a store procedure invocation. Like the Entity Framework has first-class support for which is the thing underlying, the thing I was using there, has first-class support for store procedures, so or views and stuff like that. So I could have called a store procedure there and then take the results and put them out. Of course, if you use views, you get the same capabilities. If you use store procedures do not allow for query composition. That's actually a feature, right? It's like the DBA wants to make sure you don't mess up the query. You run exactly what he wanted. So in that case, you don't get query composition. You get a fixed result back to the client. But yeah, absolutely, you get support for store procedures.
Thanks.
My question is very similar to his question. At my workplace, we rarely access database directly. We always call a middle layer application. Sometimes we call the J2E web service to get the data. So this one is going to work for that kind of scenarios?
No, not really. So this technology is designed to basically put an HTTP face over a data repository that you have. If you already have a middle tier, then this is probably not the right technology. If your goal is, let's say you have a middle tier, J2E based or any other technology, and what you want is to put an HTTP face to it, what I would imagine is, excuse me, you can take a look at, so the Windows Communication Foundation team has been building what is the base technology for what we have on top, and they provide all of the services we use for REST and HTTP and headers and formats and so on. So you can use their infrastructure directly to build your own HTTP interface to your system. Because all of this URI format assumes a lot about using a particular data model and so on. So it assumes that we have line of sight with the database in the middle tier. Not in the client, of course, but yes, in the middle tier. So I think building a WCF-based facade will be a more appropriate approach for that particular scenario. Any more questions? All right. Thanks very much, and we'll see you in MIX chat. Thank you.